All right. So hello everyone. Hope you're doing well. Today is going to be the last course of the AI series. A short one, but a must nowadays. But before we start, we're going to practice today. So if you can just go to Docker here in Google and download the Docker desktop and install it. I'm going to give you 5-10 minutes to do this, and we're going to start. Just go here and select the version for your operating system. All right, let's start. So what is Docker? Docker is just an open source platform that's going to allow you to run and create any application, software, environment as a lightweight, portable, self-sufficient container that will run virtually anywhere. So one great thing about Docker is that it can be run on Linux, macOS, Windows, WSL, which I'm going to be using today, Windows subsystem for Linux. And it's going to allow you to create your own application locally on your own operating system, and then to share it and deploy it on other operating systems, which is great because it's going to make it easy to create a consistent environment that's going to work everywhere. And it's going to avoid us the very known problem, works on my machine, right? So here, I selected the most common and important command that we're going to try to go through all of it. So again, install it, download it from Docker desktop. And let's see the first command related to the images. Images are the environment that you're going to create, and that's going to include all the packages needed to run your own application or environment. It depends. So we're going to find what we call Docker build to build your image. Again, image means environment. We put -t to tag this image and to give it a name. Then we're going to have Docker images to list all your downloaded images locally. So all the environment. Then we're going to find Docker RMI to remove the image. And finally, Docker image prune to remove all the unused images. The next are related to Docker Hub. Docker Hub is just a service provided by Docker to find and share the different images. Again, you can see it as a repository, as GitHub, where you're going to push your Docker images that you created locally and to share it with others. You can use it as public or private. It depends. So we're going to find Docker login to log in into your account for Docker desktop. Then you're going to use Docker push to push and upload your image or environment again in the Docker hub. It's like GitHub, same thing. We're going to find Docker search to look for a specific image that you like and you want to work with it. And finally, Docker pull to download this image. Now, it looks like this one. Let's see an example. So this is the Docker Hub. And you can find all different images. Imagine I'm looking for Linux. It's going to give me all the distribution for Linux. A lot of them. But imagine I want to be specific. Ubuntu, for example. It's going to give me all the images related to Ubuntu. And here I can select this one, for example, the official one from Docker, and I can select the tag and download it. Tag means the release, the version that I want, maybe 2404. And it depends. It can be also Debian, Kali Linux. You're going to find a lot. It depends on what you are looking for. Imagine I'm a data scientist. I want an environment related to Jupyter Notebook. that use all the libraries that used a data scientist. I look for Jupyter, for example, and it's going to give me a lot of images related to Jupyter. Spark, if I want to work with big data, for example. TensorFlow with GPU, for example. These are already ready to use images with the whole environment, like Jupyter Data Science Notebook. This one, I like it. I go here, and you can do a Docker pull to download this image, which is already ready. Like, you just copy this command, Docker pull, and you can start using this environment with all the libraries without any conflict and handling anything. Everything is working directly. This is why, by the way, Docker is great. It's going to avoid you all the conflicts when you are working with libraries. So again, here, this is an example of the Docker Hub where you can find and push all your environment and the images that you want to work with it. And finally, we're going to find what we call containers. These are the instance that's going to be run using the Docker image that you downloaded or created. It depends. We can create custom image, of course. So here, you can see it as a process that you're going to run from this Docker image. Yeah? Tell me.
Are you sharing these slides, or are they available in?
Yeah, I will share it. Exactly, I will share it, or I'm trying to record it and push it to YouTube. So you're going to find this session again in YouTube channel. So you're going to find it, no worry. So here, the containers, again, are process that's going to be run. You can see it as a process that's going to be run from your own local image, custom one, or the one that you downloaded. And here you're going to find, to run it, just use Docker run and the name of the image. And it's going to launch a container, an instance, running from this image. You can add some parameters to it, of course, to these containers. The name, minus name, to name the container. The P, which is very important, to publish containers ports, which means create a passerelle or tunnel between the container port and the local host, your machine. We're going to find also the V, minus V, to create a bridge. We call this volume, a bridge between the containers and your local machine. Imagine you are working with your scripts and you want to use an environment specific one. You create a bridge using minus V and create between the containers and the local machine a passerelle where you can get your local scripts running using the Docker environment. We're going to see an example of it. Then you're going to have minus D to run a container in background. Docker start and stop to start and stop a container. Docker RM to remove it. Docker execute to execute, again, a script or any process using a running container. Then Docker logs, of course, to look at the logs. And the most important one, Docker PS and Docker PS minus all. These are very important to list all the current running containers and the history of all the containers that has been executed. You need to use this a lot to check always your containers. Again, PS means process, Docker process. And this is a common Docker, typical common Docker platform workflow. Imagine you are working on a project. You like some libraries. You don't want to deal with the conflict of the libraries and everything related to Conda, create environment, or pip, or I don't know. You are working with Python, for example. You look for a specific image, like the one that you have seen, Jupyter for Data Science, for example. You download it. You find it in the Docker Hub. You download it using Docker pull, for example. Then you run a container using this image, so a process, to run some local scripts that you have been working on. So you find a very interesting library that you want to test. You have some Python scripts on your local machine. You create a bridge. You run an instance using this image. It gives you the results. The job is done. Then you stop. Next move is to stop the container, remove it, and remove an image. This is a typical common workflow. Again, here we're going to try to run a demo together. First one, is the most obvious one, of course, the hello world. And then we're gonna try to use an Ubuntu image and display hello world, this time using an Ubuntu image, Ubuntu Docker image, and execute a bash script that's gonna display hello world from inside the container and then from outside this container. And these are the different steps that you're gonna try to go through. Again, you can follow with me. If you installed your Docker, we can do it together. So the idea here is that if you installed all Docker, you can use already your terminal, or you go to Docker desktop, if you don't like your terminal, and it proposes a terminal here. You can use it directly in Docker desktop. But it should be already included in your terminal, so you can use it from here directly. All right, so we're gonna try to go through these different steps together, and let's see. First thing is to run the hello world example, right? So what's the first step that you need to do? Again, it's just docker pull hello world, right? What's it gonna do? It's gonna go through Docker Hub, look for this image, and download it locally. You can follow again with me. All right, it's downloaded. How I can check that it's in my local machine? Again, 3 commands or 2 commands that you're gonna use all the time. Docker ps, Docker images, Docker ps minus all. Remember them. So to check the images, I'm gonna use Docker images. Let's check this. Docker images. Okay, I have a lot, of course, but let's check the latest one. Okay, is there? Hello world. Okay, I found it. In your case, you're gonna find only one images, which is the hello world. Okay, so I have this image. Let's run a container, which is the process or an instance, using this Docker image. To do that, again, Docker run the name of the image. That's all. So we do Docker run hello world. All right, perfect. Hello from Docker. This message shows that your installation appears to be working correctly. You should have all this display. Now, what does it mean? If we look at, again, I told you, to the run in containers, we need to check Docker ps. If I do Docker ps, nothing, which makes sense. Why? Because if I look to Docker ps minus all, to look at the history, I can see that my containers was running 30 seconds ago and stopped. Why? Because the job of this hello world was only to display this message. This is the job of this Docker image, hello world, just to display this. So when I run a container using this Docker image, it's gonna display this. This is the job. Now, let's try to do this, display this hello world, but this time using Ubuntu image. What you're gonna do, again, you need to remember all these steps, just to be sure you can follow. These are the different steps. You can follow with me if you cannot follow my typing. What you're gonna start to do is Docker pull Ubuntu, right? To download the image. Okay, if I do this, it's gonna download the image. I already done it from the Docker Hub. Okay, perfect. So I have my Ubuntu image in my local machine. Again, to check always Docker images. Let's see. Okay, is there Ubuntu? Perfect. Now, we need to create an instance, right? Docker run Ubuntu. Let's see this, Docker run Ubuntu. Okay, what did happen here? Nothing. But it's normal. Why? Again, let's check together. Docker PS. Okay, now container is running. Let's check the next one, Docker PS minus all. Okay, I can see that there is a container run 20 seconds ago and stopped. Why? It makes sense, because it's an Ubuntu, it's fresh. I didn't give him any job to do. I just said Docker run with Ubuntu. Okay, he started the session and stopped. I didn't give him any task to do or any job. Okay, now I get it, now I understand. So next step is to give him something, right? Okay. You need to understand all these steps. So here, the next step, this time, is to give him something. So I will do Docker run, and we're gonna include some new parameters. -it, which means in terminal. I wanna be in the terminal of this new Ubuntu. Okay, so I put -it. Then let's give him a name to this container, right? So we're gonna do --name, right? We're gonna call it Ubuntu hello, for example. Right? Then the next step is just to put the name of the image, Ubuntu. This time, I'm inside the terminal of the Ubuntu coming from the Docker image, which is amazing, because now I'm inside Ubuntu, inside the Ubuntu, which is WSL that I'm using, inside Windows. So amazing. Okay, now how I get if it's a new one or not? Just look at the ls. Okay, I have all the file systems of our Ubuntu, and I can check the version, for example. As you can see, it's a cat OS release. All right, so you can see that it's a fresh Ubuntu 2404, as you can see. It's Debian, as you can see, as it has all the information here. And I could choose another version, 2504. It's already there. So it's amazing. You have a fresh Ubuntu that you can work with it. Next step, what is it? Is to try to create here, just to show you that it's an Ubuntu working. I can do all the command echo hello, for example. And let's try to create a script and display echo hello word from this script. Don't forget, we are inside the container still there. So to do this, what you're gonna do is maybe try directly to do nano, right? Or vim, as you wish, nano, hello.sh, right? If you do this, it's not gonna work. Why? Because it's fresh Ubuntu. There is nothing there. It's a lightweight image. Nothing is there. So the perfect thing you need to do first is to update the packages, right? You do apt update. It's going to update all the packages. Then, again, we have seen that nano is not there. If you want to work with vim, do the same thing. apt install nano, right? Now it's going to install it. And now I can do nano hello.sh, right? And it's gonna work. Okay, I will put echo hello world If you're not familiar with nano, Control O, and then Control X to save the file. If I do list, I can find my script here. And I can do bash .sh, and it's gonna work. Perfect, right? But again, to make it work, I need to create it here because I got into the home. So we'll do the same thing again. Control O, Control X. And if I do list, my script is here. And we were able to make it work from inside the container. Perfect. I finished my job. Now I'm going to exit this container. So to do this, exit, right? Now let's try to run this script, but this time from outside the container. In your case, what I'm going to do is just to do, if I understand the thing, docker run ubuntu bash and do this. Does it make sense for you? I mean, in your case, yes. For me, it makes sense. But if I'm going to do this, you're going to say no such file or directory. Why? Two concepts to remember all the time. Containers are independent, isolated, ephemeral. This is very important. You need to remember this. They are isolated from each other and ephemeral. Again, we can make them consistent and we can make them talk between each other, but by default, they are isolated, ephemeral, and independent. So how I can get this bash script running from outside? Let's see the command that we have seen. Docker ps, right? Nothing is running. But if I do docker ps minus all and check the previous containers, I can find mine here. You see? Where is it? It's called Ubuntu Hello. Here. Let me just reduce this to see this one. It was exited 6 minutes ago. This is my container. I found it. So here, to interact with it, either using the name or the ID, as you wish. Do whatever you want. So to do that, to get access to this container, we need to start it again. So to do this, docker start and put the ID or the name, as you wish. I'm going to choose the ID, for example. OK, I started again. How I can check this? Docker ps. OK, it's running, right? Now I have my Ubuntu, the container that I created, which is Ubuntu Hello, running, right? Let's now run something to get access to this bash script. How? Again, when you have a running container, to interact with it, you need to use docker execute, not docker run. This is a trick that you need to remember. To run a new instance, use docker run. To interact with a running and do a job with a running container, use docker execute. OK, let's do this. Docker execute. Then, like this one, docker execute. And then we're going to need to put the name of this container. So we're going to put Ubuntu Hello, right? This one, to interact with it. Then, as we did before, bash, and I put my script. And it's going to work. He found it. Because we targeted the right container that we created the bash scripts inside it. If I did as before docker run, he is not going to find it because each time he's going to create a new instance. They are isolated. Okay, now imagine you want to do another thing inside this container. To get access to it again, same thing, execute, but this time you need to add, as before, if you remember, the minus IT. And then remove this. And now I'm inside this container again. If I do ls, I can find my scripts. I can remove it, I can modify it, I can do some stuff on it. Okay, imagine you finished your job, you executed this, run your project, your scripts, you finish the job, you wanna get rid of all of this. You wanna remove all the container and the image. Things to remember. Each time you wanna remove an image, you need first to stop all the running containers using this image. All right, then you need to remove all the containers using this image. Then you can remove this Ubuntu image. In our case, if I do docker ps, still running, right? So I cannot remove this. Imagine I want to do docker aram, and I want to remove this container. I'm going to put this ID. He's not going to be able to remove it until I stop it before. So first step, look at to the all running containers that use the image that you want to remove all the time. Then do docker stop this container. It's going to stop it. Okay, perfect. If I do docker ps again, no containers are running, which is perfect. But if I do docker ps minus all, I will see that if I look at to the Ubuntu image, I have 3 already executed containers using this image. So in order to remove this Ubuntu image, I need to remove all these containers before. Why? We can do this. Docker rmi remove image Ubuntu enable, because there are some containers running or some containers already used to run some jobs using this image. So to remove them, we do docker ram. So ram to remove the containers, rmi to remove the image. And I will select all these containers here. And you can add them, of course, like this one. All right. And now if I check docker ps minus all, they are not here. Perfect. Now let's try to do docker rmi Ubuntu. Now it's deleted. And you finished your job, and nothing happened. You did your thing, and your software and operating system is clean. You see? Amazing. Perfect. We did the demo. We did the job. Now, next step is that I want you to do exactly the same thing this time. Let's exercise a little bit. I'm going to help you. Try to do exactly the same thing that we did. But instead of using an Ubuntu image this time, we're going to use Miniconda, for example. So I need you to download a new image from Docker Hub, which is called Miniconda. I give you the name here. You can look for it from Docker Hub. Run a container using this image and give it a name, my first Python scripts, for example. You create these Python scripts using Nano or Vim or wherever you want, and put hello.py and put, I don't know, print hello world, for example. Execute it from inside and then outside, and then delete it and delete everything. Let's try to do this. Give you some hints, but again, to make it easy for you, this one is better. You have all the command related to the Ubuntu that we did right now. Try to replicate this, but this time using a Miniconda. Again, you can choose another image. If you like Python, do it with the Python image. Or Conda, or mini Conda is small, but if you want a more lightweight image, you can do it with Python, for example. So let's do this, and I'm gonna help you. You're gonna go through these different steps. That way you're gonna practice, and you're gonna memorize all these commands, because you're gonna use it a lot. And I'm here, if you wanna help you. Tell me? Yeah.
Last step, you asked us to remove Ubuntu image. And how do I know I removed
No such image. You didn't
Sorry.
download it to look at for your images. You do Docker. Images, right? Okay. You have Hello World. You have this one. And Bash, for example. These are the images that you have.
Okay.
You don't have the Ubuntu.
But I downloaded
You downloaded?
Yeah, I guess. I followed
Why
your
it's
step.
not
Maybe I
there?
already
Download it.
Remove it?
Remove it. Docker pull, for example, to check if it's gonna. You did all the steps with me?
yeah.
Yeah, it's downloading it
Maybe
again.
I already removed
You
it.
remove it, yeah, exactly. You
Okay.
were following
Yeah,
with
I
me.
downloaded with you, followed your step, I guess. From the very beginning.
Yeah, Hello World, it's working fine. Ubuntu, yeah, here. You did
Yeah.
it. And you remove it, so you went
So I
through
already
the whole
removed it.
steps, yeah. But now
Okay.
you have it again.
Okay, I
Now
removed it.
try to do it with Miniconda this time, all these steps.
All right.
Using Python, not a Bash script. Tell me. Yeah.
Where does it save the Docker file and these stuff locally? After I pull the image.
It depends on which operating system you are using.
Okay, if I'm using Ubuntu.
I don't exactly know exactly where it's stored in Ubuntu, but in Windows, it's somewhere related to, don't really exactly remember. I think in Docker desktop, you're gonna find some images.vim.
Okay.
So in your case, try to look for something in your operating system, .vim.
Okay.
And look all the files, and then
Mhm.
you're gonna try to target where all these images
Okay,
are
okay.
there to move them.
Yeah.
Because I was getting the same issues, like to have a lot of images that I downloaded. I wanted to move them to another local
Okay, yeah.
local hard drive.
Because I was trying to open the container by the base code.
You can do it.
Yeah, I already do have.
Yeah,
the
exactly. You have the
extensions.
containers. You have the
But
extensions.
I need to like look at the folder itself in
Yeah.
order to see the Docker file and build it. This is another.
Yeah,
okay.
yeah.
I also have another question. Here I only downloaded or installed the Ubuntu engine. I
Yeah.
didn't install the desktop app or something.
Ah,
Is it okay?
you didn't use the Docker desktop?
No, I only installed Docker.
It's
engine.
okay. It's okay.
It's okay,
Yeah,
okay.
yeah, of course. Yeah.
Because
Docker desktop is easy for users that wanna interactive things. But
okay.
if you are just working with the command, it's
Yeah, yeah.
fine. It's fine.
Okay, sure.
So here it's perfect. You are downloading the
Yeah,
image,
I'm downloading it.
the miniconda, yeah.
Okay.
And then you're gonna try to
Yeah.
create the Python scripts.
Right.
Working. Docker run -nt. You call it miniconda example. Okay. Okay. Good. Perfect. Create your Python script. Nano.
Update, right?
Exactly. You got it.
Okay.
Tell me.
I tried to update, but it's
apt update.
yeah,
Remove the get.
the same.
Yeah, it's working. Okay. And then
It's not
do.
found.
It's okay. Just do apt install nano. Just check if it's gonna be able to install it.
No, it fails.
It fails.
Yeah.
Which version are you using?
Continuing /.
You did an AMD version. You are working on Mac,
Yeah.
so you need the ARM, not the AMD. This is why remove it. This is an AMD, this is for Windows. You selected the wrong one, so in order
But
to
shouldn't
do,
it just be a matter of
just do docker pull this image. He's gonna be able to select the one,
like this, and I can
remove the image, remove any container, then remove the image. Okay, do docker pull this image.
it's called new kind of thing.
Yeah. Otherwise, you can go to. You did docker pull. No, you need to put the continuum thing, or just go to the Docker Hub. It's better. Look for. This one, yeah, go for it. Do a docker pull, just go to, or this one, just use docker pull this. Should be directly using the right version for you. I remove this. Let's see, you're gonna be able to select the right one. You can see it in the Docker Hub. Let's just to show you. Look always in the tag to ARM, not AMD in your case, to this one. You see, this one is for AMD for Windows. In our case, is this. But it should be doing this by default. So just by doing docker pull, it should be selecting the right version. Let's see. Okay, yeah, I'll get back to it. Just.
This error, I don't know why.
What did you do? Docker pull?
Yeah, docker pull. The one that I did first was docker version. It displays this, and then I got an error, and then I tried to do docker pull. It just displays using default latest, and then I got this error.
And were you able to follow the example, the previous one, or not?
No.
No?
Yeah, because
Is it
when I
related?
installed the desktop, I got this.
It's, yeah.
I need to enable this. first.
Yeah, you need to remember this. Yeah, she got the same problems.
In BIOS or?
Virtualization support detected. Yeah, this is system requirement. I think it's something related, yes, to
The BIOS.
or just try to do this.
Okay.
First, WSL update in your terminal.
Okay.
You have the admin right?
Yeah. This is my.
Do the WSL update
Okay.
first. And the virtualization, yeah, do that. It's off in your system, you need to enable it. Okay,
Oh.
it's gonna do the stuff.
Oh, so I have to install the WSL first.
Yeah. Let's see, but the virtualization, yeah, if it didn't work, you need to activate it.
Okay.
Just look at in Google, they're gonna tell you if you need to change either, yeah, in
So
something.
to go to BIOS.
No, not the BIOS.
not
You
the
go
BIOS.
to the, I don't remember how it's called. There is a function that you're gonna need to just check and restart your system. It's gonna be enabled. But let's see,
I think I
yeah.
know what you
You remember, yeah.
mean.
But let's hope that with WSL is gonna do this by default. Okay.
And then update. Should I just reboot first or update first?
Where is it?
Change from
So
update.
rebooted, yeah. Just reboot the system. And let's check if it's gonna be enabled or not. I'll get back to you. Were you able to do it?
Not
No,
sure
no.
what this
What's
document
this?
exact. So
Don't put the slash. Why you did put the slash? Yeah, remove it like this.
Like this?
Yeah. No such
Because
file or
the file is in the home.
no, just do it in the
in
run.
the root.
Yeah, exactly. Just run your container again. Docker execute -it. Put the name of your container and do bash. Add the bash at the end.
Oh, gosh.
Okay. Do ls. The script is
So-
not here.
Oh, it should just
Create
be,
it
okay.
here. Yeah, exactly. You need to create it here. Create your script and run it. It should be working. Yeah. Tell me.
I don't know why when I
Docker
pull
pull.
the mini conda and it says does not exist.
Yeah, doesn't exist because you need to check exactly the same name. Continuum miniconda. If you go to
Conda 3. Okay.
if you go to Docker Hub, this is why I told you to go to Docker Hub and type miniconda. This one or miniconda 3. You can check here. Do miniconda 3. This one. You go here.
Okay. All right.
Just use this one. It's gonna be. You go Docker pull this. Just copy this.
I wonder now I'm in the middle pull Python.
You can stop it. You just stop it.
Just
Yeah,
stop it?
exactly.
Nothing.
No, nothing. Don't worry.
Okay.
Do the pull again and yeah. Were you able to do it?
Yeah, now I'm removing the.
The whole thing. It works
Yeah,
from
yeah.
inside and outside.
Yeah.
Perfect. Yeah. Works or not?
Yeah, works.
Works.
Yeah.
This is the right version. ARM.
Why is it that installing it from here was different then? Like I installed it when I installed it from
Was
here.
this because I don't use a lot Docker
is the-
desktop?
this
Okay.
one.
Yeah,
So
but
it's like from
here he's gonna give you all the custom images, even for someone like you or me, not
Yeah.
the official one. So someone maybe created and
Mhm.
push it,
but isn't
and you
that-
are trying to use it.
yeah.
And he pushed only a version for Windows.
So this isn't from Docker Hub. This is from
It should be from Docker Hub, I think, but you didn't select the right one. It's 3, I think. If you do 3, try with the 3. This one, the right one. And here, if you go here, for example, go here. No, the 3. Do directly a pull from here and try it. You have all the version and do the pull. Yeah, do it. It's okay. You don't before you downloaded the mini conda, not the 3 version 3, but it's okay. Did you did the same thing? A pull directly like this one
Yeah.
or not? Huh? So I told you it's a custom one. So
Mhm.
maybe it was only specific to
okay. So maybe
to Windows.
Okay.
So be sure when you're gonna do this. I mean, in your case, I preferred going to Docker Hub to see exactly the version that I showed you. If you go to Docker Hub, you see the thing that I showed you here. You can exactly know that this image contains AMD and ARM. The others, let's check it. If you do, what's the name of your version that you downloaded before? It's only
Yes,
Miniconda.
Miniconda.
Yeah, let's check. This one. Go to the tag. You see?
Okay,
There
so
is
there's
no
arm.
ARM. Exactly. So be careful. This is good. For Mac users, always look for something that include ARM and AMD. That's going to work on both. This is why it didn't work.
Okay.
Right. Yeah. Tell me.
So start here. And I know then how to.
You are Python scripts. So do print. And then do the bracket like this one, and do the, how to call it, this one. Hello. Save it, Control O.
Control.
I'm not a Mac user, so do it, yeah.
Control O.
Yeah, and Control X.
Control X.
Yeah. No. Control. This is control. I mean, in the yeah, Apple. I don't know. It's the command. Okay. I was talking in. Didn't work.
Control O, right?
Control O to overwrite.
This one, right?
Yeah. And then Control X to exit. Okay. And then do Control X to exit. Perfect. If you do ls, is there. Hello.py. Run it. And let's see.
I'm
Yeah.
doing it
Tell
through
me.
the terminal. So I don't know what I'm doing wrong. I just
Tell me. You did Docker.
so first I did Docker pull. Where am I got?
Docker pull.
Yes.
Perfect. Perfect. You did it.
I,
So
I
if
got this here,
perfect.
and then I tried to run
Docker images. Let's check together Docker images to see if your image is there. Perfect. Is there?
it. I made a
Perfect.
mistake. I installed 3, and
Yeah, it's okay.
Okay.
Yeah, this is good. It means
Yeah.
that you're experiencing. This is what.
but then I
It-
tried to run this and name it this, right?
Remove.
The bash.
Just put.
Because the thing, Miniconda is it's not a
Yeah,
not a terminal, is it?
exactly. But
but-
it's based on an image that was created using Linux and Ubuntu, for example, and
Yeah.
they install it,
Yeah.
Miniconda on it, and they just let you do this, for example.
And I
Just
keep getting this error that it's already in use.
it's already.
In use in the container. Sorry. So I think I.
Perfect. Yeah, it's already in use because you already created with this name.
But it's-
Let's do it. Docker PS. You're gonna see that it stopped.
Okay.
Docker PS. This is good exercise. Nothing is running. Docker PS minus all is there.
It's created. Okay.
It's created. You call it conda test.
Ah.
Remove it. Or just, no, don't remove it.
Yeah.
Get access to it. So start it again.
That's.
It's a good start.
Starts. Oh, yeah.
And you put the ID. You can either remove it and create a new one.
Yeah. Okay.
But in our case, let's start it again. Docker
So I can
start. And use the name or, yeah,
Okay.
as you wish. Fail to create. Fail to start it. If you put the ID,
Okay.
maybe.
Yeah. Sure.
Otherwise, let's create. Should be corporate, right? Do
Yeah.
don't know how Mac works. Okay. Try. Okay. Remove it. Maybe it's corrupted, so we don't
Okay.
care. Docker
Stop. or
RM.
RM. I. No.
I for the images. Put the ID. Perfect. Now it's removed. Do it again with the Docker and name it as you did. So you have the command docker run.
And I don't push /bin.
No, don't do it.
Back
This is the mistake that you did. Now you are inside this
Okay.
Miniconda.
Okay.
So it's got already the Python inside it, right?
Okay.
So you can create you are inside
Okay.
in Ubuntu, you see?
Yeah.
But it's got
Okay.
Anaconda on side of it also, and Python, everything is there.
So Miniconda is Ubuntu with all these things.
With
installed.
all of these things, exactly, perfect.
Okay.
So now,
Good stuff.
nano
Yeah.
hello.py, for example. It's not gonna work, right?
Yeah.
So you need to update apt update. Then apt install nano,
No.
and then you can,
Okay.
exactly.
Great. Okay.
Were you able to execute the thing from inside? No? Where are you?
Exit.
We were inside, right?
The exit ID.
Here. You did not bash this time.
Okay.
It's Python.
Okay.
So you do Python and you run the scripts. Let's do it again. So if you go to Docker PS,
Okay.
nothing is running, minus all. Here is your my Python scripts. Let's start it again. Do Docker start and put the ID. just the ID. Perfect, it started. So now, in order to get inside of it again, docker execute minus exec minus IT.
NFT.
Yeah. Put the name of your container. This one, my Python. No, don't
That's
put
put-
the.
Okay.
You wanna get inside this container running one. It's already running, and you do bash to get inside of it. Now you are inside of it. If I click list, I'm gonna find your Python scripts. If I do Python hello, it's gonna print hello world. Now you did it from inside, right? Do it from outside. So you do exit. If you look at to Docker PS this time, it's already running because we started again. So do it again, like Docker execute, but this time you can remove the IT is not necessary, or you can put it, but you're gonna remove it, we don't need it. So you're gonna do Docker PS using this container, but not bash, but Python hello.py. Now you execute it from outside.
Okay.
You get the idea?
Yeah.
You need to, yeah, exactly. Try it again and remove everything. Were you able to do it?
Yeah.
What?
Yeah.
Print. The.
Yeah.
You forgot
I
the
fixed
fix
it.
the syntax. Okay, perfect. You did it from inside. This is
Yeah,
perfect. Do
outside.
exit.
Okay.
Let's try from outside.
That would be.
Docker PS. Always check what's going on. Nothing is running.
Yeah.
You need to start again. So Docker PS minus all to get the ID. Perfect. You have your conda test.
Okay.
Do Docker start this ID. Start it again. Perfect.
Okay.
Docker PS. This way it's interesting to keep using the same command. Now it's running.
Okay. Yeah.
So you can execute a task using this container. So we do Docker execute, name of the container, conda test, for example,
Yeah. And
or the ID as you wish.
then you do the command.
Python hello, exactly.
Yeah.
You got it. And now it's working from outside.
That's good.
Now you can remove and finish your job and everything and remove everything and clean your system.
Okay.
This is the idea, yeah.
And so this is only for our computers. I understand that Ibex doesn't use Docker, right?
It's used a similar one, which is called
Singularity.
Singularity
Yeah.
or Podman.
Podman. Yeah.
Podman is the most
Yeah.
really close to Docker.
Okay.
But Singularity works on the same principle.
Yeah.
It's a container that you're gonna run and
Mhm.
use a custom image.
Mhm.
Now we are working with
Yeah. Yeah.
pre-built images that you are downloading, but you can create your own environment
Yeah.
using a custom image. I'm gonna show you how to do this.
Okay.
And when you're gonna create this, you can
Mhm.
push it to Docker Hub, to your repository,
Yeah.
keep it private or public as you wish,
Yeah.
and then you can work with this and try different stuff
Yeah,
on
yeah.
it.
Okay.
This is the idea. And it keeps everything isolated from your system.
Yeah.
So it's amazing. Yeah, exactly. This is the
Okay,
idea. Yeah.
So you would do a lot of testing on Docker because you can control everything, right?
Yeah, exactly. Exactly. And it's isolated and ephemeral. You
Yeah.
tried something, you broke all the libraries,
Yeah.
just delete the container.
Yeah.
And that's it. Nothing happened. You didn't interact with your operating system. This is the idea. This is why it's great. And it's a must nowadays to experiment and do a lot of stuff using it. Right.
Thank you.
Right. Tell me.
Execute outside finish and now
Inside
the-
you did it?
Yes, and I want to go inside
Okay.
again. How to do that?
Docker. PS. It's running, right?
Yes.
So do a docker execute this time. Put the name of your container. But this time, if you want to get inside of it, add minus 80, right? And do bash. Now you are inside of it.
Okay, thank you.
If you do ls, you're gonna find your Python scripts. And you can run it again and from inside, not outside.
Yeah,
Get it?
okay,
Yeah.
thank
Tell me, how?
It's clear.
Did it work or not?
Yeah, yeah, it worked.
Were you able to print the hello world? This is from inside?
This was from outside.
Outside.
Yeah,
Okay,
yeah,
okay,
and
perfect.
Inside was
Yeah, this one.
here. Yeah.
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 Using a bash, you were able to run a Python script?
Yeah.
Okay, I didn't know that. I didn't know that. Okay, should be Python, and you put the okay,
Yeah.
okay. This you this one. Okay, just copy this WSL update.
Gonna take time.
Go to the here and install it, and then it's gonna reboot, I think, and you're gonna be able to work with Docker. It's gonna install it, reboot, I think, at the end, and it's gonna work.
Okay.
And I get back to you to run the example. So you were able to do it, right?
Yeah, yeah,
Perfect.
yeah, yeah. Thank you.
Maybe. Did it work? Still struggling?
He's
Yeah,
comparing.
just experimenting.
Yeah, tell me.
Why do I use bash there?
in the
Where?
Miniconda
Here,
environment.
I don't use bash to run stuff. Here in Miniconda, there is bash. Why?
Where is it,
When
where
you
is it,
call
where is it?
bash and then hello.sh.
Bash is used to call text file, right? Or
Yeah,
what?
it should work with. No, here you created the bash script, but I want you to create using the Miniconda a Python script. So do nano.
It's not having.
Wait, it's not. Where is it? Oh, it was here. Nano. And here, do hello, but this time using Py.
Oh, okay.
Do here a print.
Yes. Now it makes sense to me.
Yeah, exactly. You are working with the bash, and it's gonna work because it's the Miniconda is based on Ubuntu system. Someone created an image with an Ubuntu and installed Miniconda and push it.
Yes.
This is why it works with Bash and Python. So here you can put
Hello
give-
world.
what? Hello world. Right? You put this. This one, yeah. Control O, Control X. Now if you do ls, you're gonna find two scripts: hello sh and hello Python. If you do Python now, hello, but this time Python, it's gonna run the script from Python.
Yes.
Now do it from outside. Exit this container and try to run it from outside.
From the desktop, for example, or here.
You
mean?
can do it. Do it wherever you want. But
Uh,
exit the container.
I have to exit here. This one.
Yeah. Do exit.
Exit the whole.
No.
Think?
Get out of from the container.
Okay.
Now try to execute the same script but from outside. Do docker ps.
You can do it from there. Though.
From here.
Yes,
From
you
the
already
local itself?
exited, right?
Okay.
We're already out.
Sorry.
Docker ps. Check your containers. If there is anything really
Docker
running,
PS.
nothing is running.
Yeah,
So
nothing is
do
running.
docker ps minus all.
Docker
PS minus all.
PS minus all.
Perfect.
That's
You
all.
find it. My second Python script.
Oh,
Start it again. Docker start.
My first Python script.
No, second. You have only one container.
Sorry.
Start and put the name.
My dash.
No, docker start.
Oh, sorry, I forget it.
Yeah.
Docker start.
my second Python script, or just copy the ID.
Okay. Now I click enter, right? And it should be working. Where is it?
Okay. To check if it's running, do docker ps. Perfect. Now it's running.
Yes.
How you interact with it? Docker execute. Docker exec.
Exec.
No, exec.
Exec.
Just exec.
Exec without execute?
Like this.
Exec.
Okay. Then you put the name of.
Which is Ubuntu?
No. You put the name of your container. You want to interact with your container, so you put the
not
name of your.
Ubuntu, okay.
Yeah.
My
Second Python script. No. You didn't give him any job to do. So you add
IT.
no. IT to get into the terminal.
Okay.
You add Python and you put the name of your script.
It was hello.sh.
Why? Because we are working with Python this time.
Oh, okay.
Now it works. Is it making sense for you or not?
Yeah, it makes sense now.
This is from outside now.
From the outside. Imagine you want to do some modification on this hello Python script. How to get inside of it? You do execute. Here you put the -it. Remove the Python this time because we want to get inside the container again. Now you are inside of it again. And if I do ls, I'm going to find and you do your modification on it.
Because when I work with this stuff, I don't work like this. I work from VS Code.
Of course, you can do it. Now I'm giving you an example.
Yeah.
But
I
this is just.
It's actually the same concept.
Yeah. But VS Code is batch. Yeah.
Yeah, different way of interacting with it.
No, VS Code is much better because you have the graphical user interface with the whole thing.
This is why I see it's easier.
Which is
I don't
exactly.
Like
of course, no one like Nano. This is just exercise. But here, this is a similar thing. You have all your containers and the images. All the steps that we did, you can do it from here. You can start and stop. Remove the containers.
This is much easier.
Of course.
Now,
of course.
this,
yeah, but you need to start slowly, step by step, and then I'm gonna show you that you can do this from the desktop. But you need to know these different steps.
But why here I have a graphical user interface? When I use Visual Studio, it all go to folder.
Yeah.
I get the same stuff, but in folder, not here.
Because it's different software. This is specific to Docker desktop. You can install Docker without the Docker desktop,
Yes, that's what I did.
Exactly.
But this is better.
This is better.
For
It's
me.
interactive, of course. Start,
This
stop.
is like
It's
a helper tool.
yeah,
right?
yeah, exactly. It's a tool specific to this. You can do exactly the same things.
So if I want to replace that with this, I put sudo apt and then Docker or whatever.
To what?
This exact tool.
Which will Docker desktop?
Yeah, Docker desktop.
You need to install it. You are using a Mac or?
Linux.
Yeah, there is a Docker desktop for Linux.
Okay.
You go to Docker in the Google, type Docker and get Docker desktop. Install it, you're gonna have this.
Yeah, because I think I'm using different Docker than this. This one is amazing.
It's much easier. It's interactive. It's easy.
Yeah, I didn't know about this.
Yeah, of course. But you need to go through the different. You need to understand what's going on. All this stop and then it's exactly using this command that you are using. You need to understand what's going behind all of this command here.
Wow. Okay.
Just wired.
So
Yeah.
If I click this one here.
It's gonna start. Do Docker PS. You're gonna see that something is running, but you need to start it. It's not start.
Okay. Yeah. Oh.
But you didn't give him any job here. This is why it's
Okay.
not doing nothing.
Run and then exit.
Run exit. It's like the same example as Ubuntu. Yeah, choose for exactly something that's gonna run.
Another one that has a job already.
Yeah, exactly.
Okay.
This is the idea.
This will save us a lot of time.
Of course. This is much better. Were you able to do it?
Yeah. I
Docker
just
execute?
wonder, like IT, what does this?
Yeah.
Like sometimes I
Imagine
need
you want to
this
get
one.
inside your Docker again. Here, Docker, PS. You have one running container, conda hello for example. You want to interact with your Python scripts again. You do Docker, execute, and
IT.
add IT, exactly.
Because if we don't add IT, doesn't work.
Yeah, in terminal. You want to be in terminal.
Okay.
So if you do ls, you're gonna find your Python scripts. You're gonna do some modification if you want, or remove it, or do whatever you want, and do vim. Yeah, do it again. This is good.
Why did this
Hello,
doesn't work?
yeah, exactly, modified.
Just delete.
Control, yeah, cn, okay. Now exit and try to run it again from outside. Look if it's running, docker ps first. Maybe it stopped. Still running, perfect. Do docker execute, and now you want to give him a job. So give the ID.
If I don't put the put the
He's
name.
not gonna be able to, yeah,
This is also
to,
for
yeah,
the
perfect. ID or name, and you put Python.
hello Python.
You see, perfect. You got it. Now you can remove everything. Try to remove, stop the container, remove it, and remove the image. Here, everything. Were you able to make work the visualization?
Yeah, just finished
Okay.
all of this. I just want to ask.
Tell me. It's running, perfect.
Yeah.
You wanna interact with it?
Yeah, I mean, this is a Python script, right? I can
Yeah.
just write a script from here. But why do I need to use bash instead of print hello world? Like, it's a Python script, right?
Yeah. So
I
here,
mean,
you already created, right? So
Yeah.
if you wanna do
but when
execute it from outside, you need to do
no,
docker
I
execute.
mean inside the script, inside when I try nano script.py, inside it I have to use bash hello world. Why do I need to use that? Why not
No,
print hello world?
No, you need to use Python hello world.
Python hello world?
Go
okay.
inside. Go inside that. Let's do it together.
I've
Go
already
inside.
deleted it.
No, it's running. It's there.
Oh, no, it's. Wait, what's the comment? It's. Docker.
Docker. You deleted
Yeah,
It's
I
okay.
deleted it.
the image or only do Docker PS?
PSA or PS?
PS. Okay. Do PS minus R to check the history.
Oops. Yeah, I already deleted it.
You deleted
Yeah.
the container. Create a new one.
Create a new.
Docker.
Run.
Docker run minus IT. Give it a name. Python.
Python. And
Perfect. Okay. Do
no. Oh,
Yeah, you need-
APT first.
yeah. Update. Do apt install nano. Perfect. Do nano. This time it's a Python. So do nano hello.py. Alright, here create a Python script. Do print.
Yeah, this is what I tried first, and when I tried running it, it doesn't work. But when I tried editing it and replacing it
Yeah,
with bash,
let's do it. Let's do it. And
with
yeah,
echo.
print and put the two things. Yeah, hello. Save it. Perfect. Save it. Control O, Control X. Okay. Control X. Perfect.
Oh,
Yes. Yeah.
Okay.
Do ls
OS.
to check. Is there? Do Python hello.py.
Oh, it's okay.
It's a Python script
Py-
this
yeah,
time.
yeah.
It's not a bash. This is why you get an error.
Okay.
Now it's working. If
Okay.
you do exit and try to run it from outside, you don't need. You need to start it again, of course. Do docker ps. You're gonna see that it's not working. So start it again. Docker start. Use the name. and then do docker execute. Perfect. Docker execute. Python, name of your container, and then Python hello.py. No, it's okay. Now you can remove it and remove it. You get it?
Yes, thank you.
All right. Working? Think? Perfect? Perfect. Worked? Perfect. Yeah. Works?
Yeah.
Do you need another question?
No, I don't need any.
Perfect. All right. Perfect. Yeah, I need question. Tell me.
Yeah, if I'm planning to use VS Code to like deal with the container, is it better to build the image from the host itself, then try to open it through the VS Code, or like use the diff container extension to?
No, you can. You can.
Okay.
You can. It's not a big deal. Yeah.
Okay.
It's also a good
It's
way
the
to
same.
doing it. It's okay. Exactly the same.
Okay.
And there is another way to interact with it is the dev container. Exactly. Yeah, this one.
Yeah.
And you interact directly with the
Yeah,
here
with this
running container. If you give it a name attached to a running container, do this, and he's gonna look for got it. Look for your already running container. You can interact with them directly.
Oh, okay.
Yeah.
Through here, okay.
I mean, it's much easier using VS Code.
So yeah, I can run it through the in the terminal. And
Yeah.
then go to here. And
Yeah,
then
exactly.
attach.
Or you can do it from here directly using this.
Oh, okay.
You're gonna find all your containers. You can start them here.
Oh, okay.
You see?
Yeah, it's much easier here.
Yeah, of course. And if you wanna much more easier, you go to Docker Desktop, which give you a graphical user interface, but you didn't do it. You are using VS Code.
Okay.
But it's the same.
Yeah. Thanks.
Yeah. Do it. Deleted everything. Perfect. Worked? Perfect? Okay. Continue. Everyone got it? Right? Let's continue. So here, I showed you how to use all these commands, but the most important one are the next one. Here is the solution. Everyone get through it. You get it. Now you are used to all these commands. But the most important one are these two, the ports and the volume. Why? Because no one in reality gonna be creating a container and creating a script and work inside the container using these scripts. This is not the right way of doing it, and no one gonna be doing this. Everyone here has his own Python scripts locally in his machine. So these two commands are the most important one that you're gonna use each time. The -v, which means you're gonna try to create a bridge between your local machine, so your local scripts, and the container. And this is the right way of doing it. Everyone is working on his machine, having his own local scripts, and he wanna just to test some new libraries. So for that, he's gonna pull a new image with this new library or new version of a library that he wanna test, his scripts, but he doesn't wanna create any conflicts with the dependency and working on his own machine to create this environment. So you're gonna use and pull a Docker image with the right version and create a bridge between your local machine, the host, using -v, and the container. And then he can use the library provided by the Docker image to run his script. This is the right way of doing it. Let's show you. Let's see an example of it. So this command here, as you can see, let me copy this. If I go here, this is my path, as you can see. And if I do, let me copy again the command. You see, you are used to it, right? This is the same Miniconda image that you are working with it. But this time, I added a new parameter, which is -v. And I put pwd, my working directory. I want to share my working directory with the container. And for that, I added a new directory called my code. But this one gonna be inside the container. So I created the breach. And if I'm gonna run this, it's gonna be exactly the same as before, as you did, right? This is the same Miniconda container. But if I do this time a list, you're gonna see that I found a new folder, which is my code. Okay, what's inside this my code? If I go inside of it and do a list, I will find all the materials coming from my GitHub repository for this AI workshop. And this represents exactly this. You see? My folders inside my windows. But this time, I'm interacting with them inside the container. So I can use the library pre-built using the Docker image and all the libraries to interact with my own and local script. And this is amazing. Now, we know how to do it with the volume. Next step is to publish a port. Why? Because now, again, we know how to interact with the local scripts. But imagine you are a data scientist. You want to work on some data science projects. Instead of using Miniconda, here I can exit. It's closed. Everything is there. But we understand the principle of volume. But imagine I want to work with the Jupyter data science environment. Remember the image that I showed you in the beginning? The Jupyter data science notebook that include all the libraries related to data science and AI, for example. It's already there, so I already downloaded it. So this time, I'm going to do exactly the same thing, but I'm going to publish a port. Why? Again, same thing. Use -v to create a breach between your local host, your host machine, and the container, and -p to publish a port from the container to your host machine. I know that by default, the Jupyter notebook gonna start on the port 8888. So I'm gonna publish this port and create a tunnel or passerelle on my host machine on 10,000. So if I'm gonna run this, it's gonna start a container running using Jupyter Notebook and give me a link, right? For those who are familiar with Jupyter Notebook, it's gonna be easy for you to get the idea. But if I go to this link here, and imagine I will run this directly, what's gonna happen? Nothing. It's not gonna work. Why? Because this link is provided from inside the container. The port 8888 is working from the container. This is why I created the passerelle or tunnel using the -p, and I told him to send me the 88 to 10,000 in my case. So if I'm gonna put 10,000 here, it's gonna give me the Jupyter Notebook for the data science environment with already all the libraries pre-installed. You can find Python, Julia, R, everything is there. I didn't do anything. I didn't install anything. I didn't deal with any conflicts regarding Conda environment if you want to create with pip and air, all this stuff. It's already there. And you can see that not only all the libraries are there, but I created also a breach. You remember my code? If I go here, I'm going to find all my scripts. So I can use, as you can see, the ones that I already provided in GitHub, for example, for deep learning. If you go here, you're going to find the Jupyter notebooks, and they're going to work. Why? Because this environment is already using all the necessary libraries related to the data science field. Imagine I create a new Jupyter notebook, and I'm gonna do import numpy as np, right? It's working. It's already there. Import panda PD. You see? Amazing. You didn't deal with any conflict with the libraries. It's already pre-installed. And imagine now you want to save your work here. So let's create a name for this new file. Test. What do you think? Where I can find it? It's already in my local machine because I created the breach. It's there. You see? It was created here. But at the same time, it's isolated from my operating systems. It's using the libraries and everything related to the Docker image. This is very important because when you're going to start working on projects, you're going to try and test different Docker images and different versions of different libraries, and this keeps everything clean and isolated. You work on some libraries with Python 3.9, another library needs 3.12. If you're going to do this kind of stuff in your own machine, it's going to be horrible. A lot of conflicts. But using Docker, you pull an image with 3.9 and you pull an image with 3.12. You create a breach using your local scripts and you run it from 3.9 and from 3.12. And you're going to see the results. Save everything because you created the breach between your lost machine and the container. And you finish your job, which is amazing. Amazing. This is the right way of working. Using different projects, because each project has its own specific environment and own specific libraries. All right, now we got an idea, right? How everything is working. These are very important. -p to publish a port, and -v to publish and create a breach between your host machine and the container. Now there are, just to show you some examples that what can be done using Docker also. So here, everything that we did from the beginning can be done from Docker desktop using graphical user interface. I know, it's much, much easy than using the command. But again, I want you to go through the command to know what's going behind this, because you can install Docker without the Docker desktop. So at some point, you're going to need to learn the command. If you are working on HPC, you are not going to get this Docker desktop. You're going to need to learn how to work with the command. But everything that we did can be done using this, for example. You see, these are my containers. And this is the last one that I already, Jupyter container, the one that I just created, and I can stop it, remove it. Remove the images. These are my images. You see? I can remove them. I can start them. I can start a container from them. I can create the volume from here. Same thing. You can do everything from the Docker desktop. To show you some examples that what can be done, imagine you're working on Ubuntu, you can do this kind of stuff. Like this one. Let me run a small one to show you something. And something interesting. Let's clear all this. This is another image. And you're going to see that it's going to provide me a link, which is localhost 6901. If you go here, I will have an Ubuntu running with a graphical user interface inside my browser, which is amazing. Again, it's isolated. You can create some breach using the -v, but I'm just showing you the kind of stuff that you can do, which is amazing. All this are already installed on it. I have Office, I have Sublime Text, for example. You see? Signal VS Code running on my browser. Amazing, right? I can run even a browser inside the browser. Like this one. Running Firefox inside my Chrome. Now, why is it interesting? Because imagine you want to work on something that you find very interesting on Ubuntu. You run this container, and you want to install some packages that you don't know how it's gonna, I don't know, try new library or something interesting that you find using Ubuntu. You can do it here. It's isolated. You can create wherever you want, install wherever you want. And then, if you are not happy with it, just delete the container. Another thing that you can do now is that imagine you are suspicious and you received an email, a phishing email maybe, you see? Instead of run it from your operating system, create a container, go here to this browser, and click on the link. Ah, it's a phishing one. He wanna get some information from you. Okay, I know that it's a container, it's isolated. Just close this, remove the container. That's it. Nothing happens, and you are safe. This is amazing. This is why Docker is a must nowadays. Yeah.
Virtual machine work on the same concept?
Exactly, but it's different. You can see it as a virtual machine, but not really. Virtual machine are working on hypervisor, which is simulating or virtualizing the whole operating systems, from the hardware to the software, which is very heavy. It's very heavy. Docker is different. You can see it's lightweight. It's containers. It's easy. It's portable. You can take this and run it on any machine easily to take it with you. It's different. You can see it much, much more secure and portable and lightweight. This is the idea. Docker is just virtualizing the operating system, not from the hardware to the software to the operating system, like virtual machine. This is the idea. But you can see the different kind of stuff that you can do. You get the idea. Now, another example here, I showed you an Ubuntu using graphical interface on browser. But imagine you are someone who is working on MATLAB, right? It turns out that MATLAB proposed also a Docker image, which means that you can execute, if you have a cached email, of course, you have a free license as me. And you can execute even MATLAB inside the browser. Again, why it's interesting? Imagine you are moving to another country, I don't know, you are using another computer and you don't want to deal with the installation and you don't have the path to install MATLAB. Just download the Docker image and it's gonna be easy to run it using your cast, as you can see. And I'm having MATLAB running on my browser, which is amazing. This is amazing. Like, you can do a lot of stuff. Why I'm showing you this? Because there is a huge community working on Docker. So you're gonna find a lot of images, a lot of environment. You can do a lot of stuff. Everything that you can imagine, you can do it. This is why it's amazing. Now I'm running MATLAB on a browser, which is amazing. So you can do it on another computer easily. Yeah.
So, but you'll always be limited by your laptop. So
Exactly.
lots of processing power. You could probably do the same thing, but on a workstation or.
This is the idea. This is the idea. Now everything is on my working locally using my resources of the PC on my laptop. But imagine you are working on HPC where you have, or maybe a very strong workstation, supercomputer. You can do the same thing. And you can work on a browser, but you are using the resources of the supercomputer, which is great, amazing. And again, everything can be modified here, as you can see. You can put some RAM, the number of the RAM that you want to share. Here I'm putting 4 GB, for example, to give the RAM. Same thing for MATLAB. And you're going to publish the ports and everything. So these are the kind of stuff that can be done using Docker, which is amazing. Now, again, last steps is that now everything you are doing are using a pre-built images, right? But you can also go a step further and use a custom image using Dockerfile. You want to build your own image, your own environment. You can do it using Dockerfile. How? Let me show you an example. This is a small example of how you can build your custom image. Imagine you like the Miniconda image. Not really. You can also use a Jupyter Data Science. But you want to add from this image some new libraries. You want to add Streamlit. You want to add TensorFlow. You want to add PyTorch. I don't know. What you can do is just create a Docker file like this one and put from, and you put the name of the image that you liked. Maybe here, Miniconda, but it can be Jupyter Data Science or TensorFlow GPU. And then you create a working directory, as here, and install all the libraries that you find interesting. In my case, I created small custom image that run Miniconda, and I created the environment, conda install, Python 3.9, I could choose 3.12, wherever. JupyterLab, NumPy, Panda, Matplotlib, I do whatever I want. I could choose Seaborn, add other libraries, and then expose the port, because we know that Jupyter Notebook is working on 8888, and run a command, which is bash, echo this, JupyterLab is running at this, and run this command, which is JupyterLab. Now I have a custom image. How to build it? Just use Docker build and put a tag to it, which means a name to it, like this one. Let me remove this. Docker build. Let me copy this. Already executed, I think. Yeah. Just do Docker build, knowing that I have this Docker file always. So to check this, do ls. I have my Docker file, this file, and do Docker build, and put -t to tag this image and give it a name. And we put a dot here to take everything inside this repository. If you have your Python scripts, it's going to be included directly into the Docker image. This is why I put the dot. And if I do this, it's going to build my custom image, which is called this time my Miniconda JupyterLab, right? So now I have a custom image that I just created, and I can run an instance as before, as you can see here. Docker run. By the way, -rm means just that when the container gonna finish his job, or I wanna close this container or exit this container, it's gonna remove it automatically. This is why we add -rm to make it easy, to not stop it and remove it each time. Now, I put it inside the Docker run command, and it's gonna remove it when the job is finished. Now I created my own custom image, and this time, if I do Docker run, it's gonna run a new JupyterLab, but this time same thing. It's not 8888, but 10,000, right? This time using my custom image, which is different, and it's amazing because now you can create wherever you want. Imagine you liked the Jupyter Data Science library, and you want to add some new libraries on it. Just do here, instead of from Miniconda, do from Jupyter Data Science, and install new libraries, PyTorch, TensorFlow, and name it my own image. And it's gonna be yours with your own custom libraries. And you can do your stuff. And what's very amazing on that is that now that I have this image, which is called my Miniconda JupyterLab, my own, I can push it to Docker Hub and keep it either private or public public to everyone. Even you can download it and work with it. Or keep it private if you want to work only on some specific custom, very specific project that you don't want to share anything related to it. And then it's saved there, and you can use it wherever you want. And again, you can add to this custom image, this command, a breach -v to work using your local scripts. Now imagine that I finished my job and finished everything, but I found a new library interested. What can be done? Just go to your Docker file and add Seaborn, for example. I want to install Seaborn also, add this library. What can be done is just need to run Docker build again. And it's going to include this Seaborn. And if you want to tag it to be sure that it's an image using Seaborn, you can add some stuff like this. Like this. And put tag to it, Seaborn. Or, I don't know, V1. Then you install the new library, another one, V2, V3. And how you're gonna be able to localize everything. If you pushed everything there, you're gonna find something similar to this. If you go to, for example, to my Docker hub, just to show you. So this is, for example, my repository, mine. And if you go here, I don't know, let's select this one. I created this custom image that I'm working with it and put some tags to it. 2025, V4, V3, V1. And then keep updating each time this image with new libraries, or updating new version of libraries, or adding some new libraries that I liked. You see? And you keep tracking everything, and everything is related to the same image, but with different tags. So maybe I'm gonna, for the version 4, use PyTorch version 2.8, but for the version 3, 2.1 or something like this. You see? It's amazing. It's very, you need to start working with Docker and do all these stuff. It's gonna make your life easy. And to finish, last step is imagine now that you are working on a project, you finish it, create an app for it, you can Dockerize this app now. Imagine you don't want to share your Python scripts or your Python, I don't know, scripts. You don't want to share them with the client or your colleagues or something like this. You create an application for it and Dockerize it and share only the application. How? You remember in the machine learning course, the heart disease app? You can do exactly similar thing to this. Create an application for it using Docker file like this one. Here, to create this heart disease app, I know that I need only Python 3.9. I don't need Miniconda or Jupyter heavy image. No, I want a light image. So I'm gonna start with an image that include only Python. Then create my working directory, put my Python script there. I copy this into my working directory, and then run some system dependencies and install all the libraries that I need to run my application. Streamlit, Panda, Matplotlib, scikit-learn, Streamlit, Sharp, for example. Then expose the port, because I know that Streamlit dashboards works on 8501, and run this command. Now, using Docker build, I created an app and Dockerize it. And then the next step is to push it and make it either public or private. In your case here, you can get this heart disease because I publish it and push it. As you can see here, let me check where is it. Heart disease. I make it public. So you can find it. And just by running this command in your operating system, you're gonna find exactly the same thing as me. This one. You're gonna get if I go to 8501, it's gonna run, and you're gonna have an application running directly without dealing with any library and any conflict. So here you have an application running, so I can browse my files, look for the heart disease, upload it. I have my data frame here. Go to data cleaning, remove all the duplicates, do some cleaning on my data, as you can see. It's clean, perfect. Do the model training, look for some machine learning models, as you can see, play with the parameters, and do train the model. And it's gonna give you all the results and working without dealing with anything. And it's gonna give you the sharp value, which means the most important features for the heart disease. Then you can go to model prediction. I have a new patient with these new parameters, and I'm gonna predict using the trained model that I already did, if you're gonna have heart disease or not. If I do make prediction, it's positive at 76% sure you're gonna have heart disease. Play with the parameters again, change it, make a prediction. Same, 70, you see? You have everything running. Amazing. Now you Dockerized your application. And you can share it with your colleagues and your client without dealing with anything related to scripts, creating a conda environment, creating an environment that's gonna make this app works. Everything is Dockerized and easy. Now imagine even the case of Docker run is too much for the client or for your colleagues. You can run this dashboard using your local machine and share the link using your IP address if you are in the same network, and you're gonna access to it. And you're gonna play with it using your IP address 8501. Now imagine you don't wanna share your IP address. You can host it in Netlify or Vercel, I don't know. So you can find something. You host the Docker image there, and it's gonna give you a link that you can share, which is amazing. And that's it for today. You're gonna have an idea about what is Docker and how to deal with it and to work with it. And this is the end of the AI workshop series. I hope that you get something from it and learn something at least. And thank you all. Thanks. If you have any question, just tell me. Yeah, thanks.